Hey, I'm Adam Eckler. In this video, I'm going to talk about the Calc 2 project part 3. In this Calc 2 class, we've talked a lot about the SIR model. The SIR model is a mathematical model that represents the susceptible, infected, and recovered people in a population. It also helps us find the amount of people that need to be recovered to reach what's called herd immunity. For this final project, me and my group had to understand the model itself, explore with the model, use the model for specific examples, and finally, ponder a further question with the model. In this video, I'll go over part 3, which is the further investigation. For part 3, we chose to cover question C, which is, what complications might exist in the real world when it comes to attaining the required fraction? And in a free society, how much force can we use to require immunization? We'll tackle that first, more objective part to begin with. The first part of this question is the complications that comes to attaining the required fraction. Now, in my opinion, this question is a little bit poorly written. It just says the required fraction. Which fraction? The complication in getting the percent of a population to the correct recovered amount for herd immunity, or the difficulty figuring out the contact number, which is also a fraction. Based on the second part of the question, I think it's getting to herd immunity, so that's what I'll be answering in this video. The difficulty in reaching herd immunity, to state the obvious, is individual choice and individual action. If the people in a population take measures like wearing masks or washing hands or getting vaccinated, it makes it harder for the disease to spread, in effect, lowering the transmission coefficient. I thought that I should add right here that taking measures like wearing masks and washing your hands and staying at home doesn't technically lower the transmission coefficient because it doesn't change any properties of the virus itself, but it can have the effect of lowering the transmission coefficient because it does make it harder for the disease to spread. And then vaccination doesn't actually work with the transmission coefficient at all. What it does is it simply takes a person from the susceptible group and just moves them to the recovered group, which helps reach that recovered amount for herd immunity. And we know that R, the population needed for herd immunity, equals 1 minus 1 over C, the transmission coefficient. So by lowering C with masks and washing hands and staying at home, we make it much easier to reach herd immunity. But if people don't mask up and they don't wash their hands, and they don't stay home and they don't get vaccinated, it makes it harder to reach herd immunity. And that's why individual choice is like the number one factor when it comes to reaching herd immunity. So if herd immunity is so great, then why can't the government just enforce individual actions to reach it? And that's a tough question. It's very ambiguous. In my personal opinion, it's a question of whether you think that these choices and actions are a personal freedom issue or a public health issue. If it's a personal freedom issue, like whether or not you brush your teeth, for example, then the government may have very little they can do or say about it. But if it's a public health issue, like, say, going 80 in a school zone, then the government may be more justified to take real action. And I'd argue that it's a public health issue, because in the context of a severe disease, your action or lack thereof can and will cause the sickness and possibly death of others. This has been part 3 of the Calc 2 final project. Thanks for watching.